In this program, our discussion of the causes and steps required to avoid burning will target 7 basic areas. These are the basic characteristics of grinding wheels, the hardness of the material being ground, other grinding-related factors, dressing-related problems, and coolant. We'll also be talking about the inspection procedures used for detecting burn-related problems. And finally, we'll look at some actual examples of burned parts and discuss how they were burned. So to begin, let's talk about the basic characteristics of grinding wheels. While any part can be burned during grinding, it's easiest to burn a hardened part. And the harder the part, the easier it is to burn. So when grinding parts, it's very important that you're using the correct wheel for the hardness of the part and the surface finish requirements. We have to watch out for other grinding-related factors. The ones we'll be covering are feed rate, surface speed of the wheel, balance of the wheel, and run out in the part. As we mentioned before, grinding is performed by the abrasive particles of the wheel removing small chips from the surface of the part. But as grinding takes place, the sharp edges of the abrasive grains break off. These particles and some of the material that has been removed from the part form what is called swarf. And the swarf fills in the spaces between the remaining abrasive particles. A wheel in this condition is referred to as being loaded, and it will no longer grind properly because it is now smoother than before. In other words, the sharp cutting edges of the wheel have been minimized. A loaded wheel will easily burn parts because the material on the surface of the part is rubbed off rather than being cleanly ground off. This means the heat generated stays on the surface of the part, and a burn can result. Proper position of the coolant supply lines is very critical. The coolant nozzles must be positioned so that the rotation of the grinding wheel pulls the coolant into the point of grinding contact. If positioned incorrectly, the rotation of the grinding wheel will push the coolant away from the point of grinding contact. The coolant is used for flushing the swarf out of the wheel and away from the part. But keep in mind, there is a potential situation that can inhibit the swarf from being flushed away properly. This can be caused by magnetism in the part. If a part is magnetized, the small particles of the parent metal in the swarf can cling to the surface of the part. As this metal is pulled through the point of grinding contact, it can create excessive heat that can lead to burning. Also keep in mind that a part with grinding cracks may not always show signs of retempering or rehardening during surface temper inspection. In some instances, a part can be severely burned and cracked during its initial contact with the grinding wheel, but during grinding, enough material is removed to clean up the burned surface. In other words, the part is no longer retempered or rehardened, but cracks are still present.